Welcome to today's paper reading. Today's paper is titled, Chain of Note, Enhancing Robustness in Retrieval-Augmented Language Models. This paper was published on EMNLP 2024 by Wenhao and colleagues from Kaixin AI Lab. The Chain of Note, CON, is a new method designed to enhance the robustness of Retrieval-Augmented Language Models, RALMs, when dealing with noisy or irrelevant documents. The central concept of CON involves creating sequential reading notes for each retrieved document, which allows for a comprehensive assessment of their relevance to the posed question. This information is then integrated to formulate the final response. Experimental results indicate that when equipped with CON, GPT-4 surpasses the performance of the Chain of Thought approach. Additionally, GPT-4 was used to generate 10,000 CON data points, which were then used to train the Llama 2 7B model. Across 4 open-domain QA benchmarks, RALMs fine-tuned with CON demonstrated significant improvements over standard fine-tuned RALMs. Retrieval-Augmented Language Models, RALMs, offer significant advancements by reducing factual hallucinations, injecting up-to-date knowledge, and enhancing domain-specific expertise. However, current RALMs face issues such as the retrieval of irrelevant data and the tendency of large language models, LLMs, to hallucinate. To address these limitations, the Chain of Note, CON, framework is introduced. CON generates sequential reading notes for retrieved documents, ensuring a systematic assessment of their relevance to the input question. This approach enhances the robustness of RALMs by filtering out irrelevant content and improving the model's ability to acknowledge its limitations. Figure 1 illustrates the core concept of Chain of Note, CON, a framework designed to enhance the robustness of Retrieval-Augmented Language Models, RALMs. Unlike current RALMs, CON generates sequential reading notes for each retrieved document. This process ensures a thorough evaluation of the document's relevance to the input question before formulating the final response. By systematically assessing the pertinence of each document, CON identifies the most critical and reliable information, thereby filtering out irrelevant or less trustworthy content. This leads to more accurate and contextually relevant responses, improving the overall performance and reliability of RALMs. The Chain of Note, CON, framework represents an innovative advancement for Retrieval-Augmented Language Models, RALMs. This framework generates sequential reading notes for the retrieved documents, enabling a systematic evaluation of the relevance and accuracy of information. By creating these notes, the model assesses the pertinence of each document to the query and identifies the most critical and reliable pieces of information. This process helps in filtering out irrelevant or less trustworthy content, leading to more accurate and contextually relevant responses. The implementation of the CON framework involves 3 key steps: designing the notes, collecting the data, and training the model. Figure 2 provides a detailed illustration of the Chain of Note, CON, framework, which is designed to enhance the capabilities of Retrieval-Augmented Language Models, RALMs. The framework is depicted with 3 distinct types of reading notes. Type A shows the scenario where the language model identifies a document that directly answers the query, resulting in a final answer based on the retrieved information. Type B represents situations where the retrieved document does not directly answer the query but provides useful contextual insights, allowing the language model to integrate this context with its inherent knowledge to deduce an answer. Type C illustrates instances where the language model encounters irrelevant documents and lacks the necessary knowledge to respond, leading to an unknown answer. This figure highlights the CON framework's ability to adaptively process information, balancing direct information retrieval, contextual inference, and the recognition of its knowledge boundaries. By creating sequential reading notes, the model not only assesses the pertinence of each document to the query but also identifies the most critical and reliable pieces of information within these documents, leading to more accurate and contextually relevant responses. Table 1 provides a summary of the dataset statistics used in the recall evaluation based on the DPR retrieval method on the full test set. The table highlights the full size of each dataset and the corresponding IR recall percentages. For instance, the natural questions (NQ) dataset has a full size of 3,610 with an IR recall of 73.82%. Similarly, the Trivia QA dataset, with a full size of 7,993, achieves an IR recall of 89.95%. The WebQ dataset, with a full size of 2,032, shows an IR recall of 64.22%. These statistics are crucial for understanding the performance of the retrieval system across different datasets and for evaluating the overall effectiveness of the retrieval process in open-domain question-answering tasks. The experiments were conducted using 3 benchmark datasets, NQ, Trivia QA, and WebQ, with real-time QA used to evaluate robustness. The evaluation was split into full set and subset evaluations to assess overall and noise-specific performance. Baseline methods included chain-OF note, CON, QA fine-tune without information retrieval, and retrieve-read with CON. Evaluation metrics used were exact match, EM, F1 score, reject rate, RR, for unknown robustness, and accuracy for GPT-4 due to its unique evaluation challenges. Figure 3 presents the performance of a hybrid training strategy in comparison to standard RALMs. While this strategy shows slightly lower robustness across various noise ratios, it consistently achieves better performance. This suggests that the hybrid approach, despite its vulnerability to noise, offers significant advantages in overall effectiveness when compared to traditional methods. Table 2 highlights the performance of the RALM model when enhanced with chain-OF note, CON. It shows a slight increase in effectiveness across full test sets and a notable advantage in situations with noisy documents. This suggests that CON significantly boosts the model's ability to handle noise, making it more robust and reliable in various operational contexts. Table 3 presents the evaluation of noise robustness using the Llama 2 7B model. The chain-OF note framework demonstrates superior performance compared to the standard RALM system, especially at higher noise ratios. The table highlights an average improvement of plus 7.9 in EM scores on fully noisy documents across 3 open-domain QA datasets. This improvement underscores the effectiveness of chain-OF note in handling noisy information and maintaining robust performance in retrieval-augmented settings. Table 4 presents the evaluation of our RALM equipped with CON on unknown robustness, particularly in the real-time QA benchmark. This benchmark tests scenarios completely outside the model's pre-training domain, yet our method demonstrates superior performance compared to the standard RALM system. A notable improvement of plus 10.5 in the reject rate, RR, is observed, indicating the model's enhanced ability to reject answering questions in unknown scenarios. This robustness showcases the effectiveness of CON in handling real-time information not included in the pre-training data. Table 5 presents a detailed comparison of inference times, specifically focusing on the average decoding time per example when utilizing 8 times A100 GPUs. This table is crucial for understanding the efficiency of different models in terms of their computational requirements, and the speed at which they can process and decode information. By examining the average decoding times, researchers and practitioners can make informed decisions about which models are most suitable for their specific needs in terms of both performance and resource utilization. Retrieval-Augmented Language Models, or RALMs, represent a significant advancement in natural language processing. These models combine the capabilities of large language models with the specificity and detail provided by external knowledge sources. This integration enhances the model's ability to process language more accurately and effectively. By incorporating diverse external knowledge sources, RALMs are able to provide detailed and specific information, thereby addressing knowledge gaps and improving overall model performance. The chain-OF note, CON, framework is introduced in this paper to enhance the robustness of retrieval-augmented language models, RALMs. The CON framework generates sequential reading notes for each retrieved document, allowing for a thorough assessment of document relevance to the posed question and aiding in synthesizing this information to craft the final answer. Experimental results demonstrate that GPT-4, when equipped with CON, outperforms the chain-OF thought approach. Additionally, GPT-4 was used to create 10,000 CON data points, which were then used to train a Llama 2 7B model. Performance evaluations across 4 open-domain QA benchmarks show that RALMs equipped with Khan significantly outperform standard fine-tuned RALMs. The chain-OF note, Khan, approach faces significant limitations, primarily due to its increased inference costs. This is caused by the sequential generation of notes, which leads to longer response times. This is particularly problematic for applications where time sensitivity is crucial. Additionally, the efficiency of the system is not consistent and depends on the conciseness and relevance of the notes generated, which can vary based on the complexity of the documents retrieved. Performance metrics, such as EM score, show that while the NQ standard RALM performs well, the RALM with CON hybrid approach has its own set of challenges. Thank you for watching.